Hello, in this tutorial we'll be dealing with question based on circle. Here we are given that O is the center of the circle. So this point right here is the center of the circle and SR is a diameter. So this line passes through the center of the circle and of course it is a diameter. And if PO is perpendicular to SR, if PO, so this is perpendicular to SR, we can see here nice little 90-degree representation, and with this information we have to prove that angle QTR, so angle QTR is this angle right over here, is equal to angle OPR. So OPR is this angle right over here. This is what we have to prove. So before trying to interpret this question, I'm going to join point S and Q through the line SQ. Now let us start our interpretation. We can see here that this triangle SRQ is standing on a semicircle SQR. So this angle SQR must be 90 degrees. Since angle in a semicircle is 90 degree, we have to remember this property. We have to know this property of a circle. It is a very important property, in fact. So here is our 90 degree, and I will assume that the value for angle SRQ is x degree. So if we look into the triangle SQR, we can see that we can say that angle RSQ plus angle SRQ plus angle SQR is equal to 180 degrees, since they are the sum of angles in a triangle. And for this angle SRQ, I'm going to write it as it is, but for this SRQ I have assumed it to be x degree, and angle SQR we know it is 90 degree, so it equal to 180 degree. Again, if I try to solve this equation, what I have is I'll write angle SRQ on one side, and I'll take 90 and x to the other side. So positive 90 becomes negative, so 180 minus 90 is 90 degree, and this positive x become negative x. So the value for angle RSQ is 90 degree minus x degree. Now I will take another triangle, which is triangle POR. So in triangle POR, we can see that POR, this angle POR is equal to 90 degrees. So if I add POR and PRO and OPR, I should once again get 180 degree. Since I'm considering this triangle, the sum of angles in triangle should give 180 degree, and I'm going to substitute the value for POR, which is 90 degree, and for PRO x degree, and OPR, which I'm going to write it as it is equal to 180 degree. Now if I simplify this part, what I get is the value for angle OPR is equal to, if I take 90 to the other side, I have 90, and x to the other side becomes negative x. So angle OPR is equal to 90 degree minus x degree. Now if we look closely, we can see that the value for angle RSQ and value for angle OPR, they are both 90 degree minus x degree. So we can simply write in as a conclusion that angle RSQ is equal to angle OPR, since they are both equal to 90 degree minus x degree. Again, if I look at angle QTR, it is standing on the arc QR. So any inscribed angle standing on uh, the arc is equal to half of the length of that arc. So angle QTR is half of arc QR. Similarly, angle RSQ, it is also standing on the arc RQ. So I can write angle RSQ is equal to half of arc RQ or QR. It's the same thing. In conclusion, since they are equal, we can also write that these two angles must be equal, that angle QTR is equal to angle RSQ. Since they are inscribed angle standing on the same arc RQ, they must be equal. Now, from these two conclusions, we can say that RSQ is equal to angle QTR. RSQ is also equal to angle OPR. So from these two, we can say angle QTR should equal to angle OPR. OPR in conclusion from these two statements, first and second. So this is what we have to prove according to our question. I hope it is clear to you, and thanks for watching.